This is the Databricks Data Engineer podcast. Writing code is the most honest work a data engineer does. It's the part you can point to, the part that ships, the part you can defend in any review. So here's the question that should bother you. Why do the engineers who write the most of it keep getting passed over for the ones who barely touch the keyboard? By the end, you'll be able to look at your own week and tell which of your work is building your case for staff, and which of it is quietly capping you. I keep hearing a version of the same story from engineers who reach out, and it's always the same shape. They're shipping more than anyone on the team. And somehow that's becoming the problem. So let's actually look at it. Let me give the keyboard its due first, because the take I'm about to make only lands if we're honest about what code is worth. Code is the deliverable. It's the thing that exists at the end of the day that didn't exist in the morning. When you're junior, writing more of it is exactly the right move. You're building the muscle, learning the platform in your hands, not in theory. The engineer who ships 40 pull requests a quarter in their first 2 years is doing precisely what they should be doing. Volume is how you earn the right to an opinion. So this is not an episode about how code doesn't matter. Code is the foundation. Hold on to that because I'm about to complicate it. Here's the thing that should keep you up at night. The exact behavior that makes you great at mid-level is the behavior that gets you stuck there. Picture two engineers, same team, both 5 years in, both sharp. Call them Mark and Sam. You're looking at their last quarter side by side, the way a promotion committee would. Mark shipped 47 pull requests across 3 pipelines. Reliable, fast, never blocks anyone. Sam shipped 9 in a whole quarter. If you measured them on a dashboard, Mark wins by a mile. Lines of code, notebooks delivered, tickets closed. It isn't close. Sam got the staff promotion. Mark got a kind note about continuing to demonstrate impact. Now, your first instinct is the right instinct to interrogate. You're thinking, Sam was probably in meetings all day. That's not engineering, that's politics. Hold that thought, because we're going to put it on trial later. First, one of Sam's 9 pull requests. It was 14 lines. 14. A change to how one upstream table got partitioned before a downstream team consumed it. The kind of diff you'd approve in 30 seconds without thinking. Except those 14 lines didn't exist in a vacuum. Before Sam wrote them, there were 4 hours of conversation. Sam noticed that 3 different teams were about to build 3 different versions of nearly the same aggregation, each one slightly wrong in a way that wouldn't surface until quarter-end close. So Sam got those 3 teams into a room, figured out what they actually needed, and wrote 14 lines that meant 2 of those teams didn't have to build anything at all. Here's what that change actually was. 6 months of cleanup that never happened. A quarter-end data quality incident that never fired. None of that shows up in a pull request count. All of it shows up in whether the platform is still standing in a year. That's the shape I want to name. I call it the inverse output curve. As you climb, your visible code output goes down, while your actual leverage goes up. The 2 lines cross somewhere around the senior level, and the engineers who don't feel that crossing happen keep optimizing the line that's supposed to be falling. Sound familiar? Let me make the case with the evidence, because one story is an anecdote. The pattern is the argument. Engineers say, I shipped more than anyone this quarter. The platform says, half of it was rework that a 15-minute conversation would have prevented. Teams say, we move fast, look at our velocity. The on-call rotation says, the same 3 pipelines page every Monday, and nobody has time to fix the cause because everyone's too busy shipping the next thing. Managers say, I can see exactly what Marek did this quarter. It's right here in the commit history. And they're right. That's the trap. Mark's work is legible. Sam's work is the absence of work that would otherwise have existed. And you cannot put a ticket number on a problem that never happened. That last one is the whole game. The most valuable work a senior engineer does is invisible by construction. You can't see prevented work. You can only see produced work. So we measure the thing we can see and wonder why our best people seem to do less of it. So let me name the 3 categories of senior work that produce exactly 0 code, because once you can name them, you can do them on purpose instead of stumbling into them. The first is scope narrowing. A request comes in to build something big, and the senior engineer's job is to figure out the smaller thing that actually solves the problem. Someone asks for a real-time pipeline. The senior asks what decision the data feeds, learns it's a report someone reads on Monday mornings, and the whole real-time build evaporates into a scheduled job that runs Sunday night. Weeks of work gone because someone asked one question. 0 lines of code. Enormous leverage. The second is decision clearing. Teams don't stall because the code is hard. They stall because 3 people disagree about an approach and nobody will make the call. The senior engineer walks into that, surfaces the actual disagreement, and unblocks 4 people who were quietly stuck for 2 weeks. The artifact is a decision in a thread, not a commit, but 4 blocked people just got their week back. The third is rework prevention. This is Sam's 14 lines. It's seeing the collision coming before anyone's built into it. It's the design review comment that saves a team from a pattern that would have haunted them at scale. It's the most senior skill of all, because it requires you to see the system, not just your corner of it. Scope narrowing, decision clearing, rework prevention. None of them ship code. All of them are why Sam got the staff offer. Now, I promised we'd put your objection on trial, and I meant it. Let me steelman the other side as hard as I can, because if I can't, this take isn't strong enough to make. Here's the best case against everything I just said. There's an engineer, call him Steve, who heard the inverse output curve as permission to stop coding. Steve goes to a lot of meetings now. Steve aligns stakeholders. Steve drives clarity. And Steve hasn't shipped anything real in 2 quarters. His team has quietly stopped inviting him to the technical discussions because when he shows up, it's obvious he hasn't touched the platform in months. Steve read the curve as a license to coast. And it made him useless. That's a real failure mode, and it's not rare. Less code is not the goal. Less code is the symptom of a specific thing. And if you chase the symptom without the cause, you become Steve. The cause is leverage. Sam writes less code because each thing Sam does removes more future work than it creates. Steve writes less code because Steve does less. Those look identical on a dashboard, and they are opposites in reality. So here's the honest boundary, the place where the take doesn't apply. If you're in your first 2 or 3 years, ignore most of this. Write the code, ship the volume, build the instinct in your hands, because you cannot narrow a scope you don't understand or prevent rework you've never had to clean up. The curve is earned or not declared, and it doesn't apply evenly even at the senior level. A team standing up a new platform from nothing needs people who write a lot of code right now. The curve is real, but it's not a law of physics. It's a tendency that gets stronger as your platform matures and your blast radius grows. So, who's actually guilty here? Because it's tempting to make this a story about engineers who measure themselves wrong, and that's only half of it. Yes, there's an engineer who keeps reaching for the keyboard because shipping feels safe and a conversation feels risky. That's real. That engineer is choosing the legible work over the leveraged work, because the legible work can be argued with. But the other half is a system that rewards exactly that. The throughput dashboard. The stand-up that asks what you shipped and never what you prevented. The review template with a field for deliverables and no field for disasters averted. When the only thing you measure is output, you train your best engineers to produce output, and then you're confused when they don't grow. The engineer is responding rationally to the signal they are given. Fix the signal and the behavior follows. The resolution needs both. The engineer has to start treating prevented work as real work and learn to make it legible. And the system has to start asking what got prevented, not just what got shipped. That's what I've got for you today. So here's the one thing to carry out of this. Next time you're about to write something, ask one question before your hands hit the keyboard. Is this code I should write? Or is this code I should have a conversation about first? Most of the time the answer is write it. But the times the answer is have the conversation are the times that compound. And nobody ever taught you to look for those. The funny part is the engineers who internalize this don't end up working less. They end up working on the things that were always the actual job, and the keyboard was just the part that was easy to see. You're not being asked to care less about your craft. You're being asked to point it at the thing that moves. If this reframed even one piece of work you were about to ship this week, send it to the engineer on your team who ships the most and wonders why it isn't landing. See you next time.